We have started with data types, right?
Yeah.
And I think, yeah. So we have seen integers. So let's continue from there. The next data type that we will see is float. So we've seen the float literals. The data type is float. Let's say f equal to or f1 equal to 50.67. Let's print the value of f1 and print that data type. How to print the data type of any variable?
Type
Function, right? Type of f1. So we get the value and we get class float. So float is the data type.
Hey, wait! Are you enjoying the video? Well, you're definitely going to enjoy an absolutely free personalized career counseling call with our counselors. Call on the number below and book your slot today.
So all the arithmetic operations also here also can be performed with float and float. Also with integers and float, arithmetic operations are allowed because logically that should be allowed, right? But one thing to note here is, let's say num1 or num1 equal to 10, num2 equal to 20.5, and result res equal to num1 plus num2. Print res. What should be the output here? What will be the output?
30.5.
30.5. Yeah, this is possible, right? So there's no problem there. Next is complex data type. So complex, as we have seen, it is A plus B, J. A is the real part, B is the imaginary part. Okay, so for example, C1 equal to 4 plus 6J, right? So 4 is the imaginary part and 6 is the real, sorry, 4 is the real part, 6 is the imaginary part. You can actually print them separately by using this attribute C1 dot real will give you 4.0. So remember that always it will give this in float, not in int. Whatever data type it is, it will always give the value in float. Okay, and we can do print of C1 dot imag imaginary, give you 6.0. Okay. Complex number also can be represented as 8.5 minus 7.1 J. Right here also you can basically print the values of real and imaginary for C2, 8.5 and 7. Minus 7.1 here, because minus sign is there, it always will be in this format, A plus Bj. So this minus sign is for this minus 7.1. Clear?
Yes.
And when you print the data type of this, anyone C1 or C2 will give you class complex. Okay. And we have C1 and C2. So C3 equal to C1 plus C2, let's say we do. What will happen? So the value of C1 is this, value of C2 is this. So I've not used print here, print statement, because in Jupyter Notebook, the last line of the cell is automatically printed. Okay, so if print is not required. So what it will do here, if I do C1 plus C2,
it will give the answer 12.5 minus 1.1.
minus 1.1j. So real part will be added separately. The imaginary part will be added separately. So the real part of C1 is 4, will be added to 8.5, 12.5. Then plus 6 will be added with minus 7.1. So 6 minus 7.1?
It's minus 1.1.
Minus 1.9.
Minus
1.
C3, 1.09. 111. Oh, 1 minus 1.1 it is. Okay. But internally it is doing some calculation. So the value is coming like this. But it is approximately 1.1. Right? What will happen if I do multiplication? Let's take C1 equal to, let's take this value only. And let's take a PC value. Let's say 3 minus 2j. Okay. If I do a result equal to C1 multiplied by C2. So this is how you do multiplication operation. So if I do C1 multiplied by C2, is this possible first of all? Can two complex numbers be multiplied?
Yes, this is possible.
So what is the output here? How it will work?
It will be 24 plus what? Plus 10j.
24 plus 10j. What is happening here is, so this guy multiplied by this we are doing. So 4 will be multiplied first with 3. So 12. Next 4 will be multiplied by
2j.
2j. So it is
Minus
minus
3.
2j, right? Minus
8j.
8j. Next, the 6j will be multiplied by 3
Plus 18j.
plus 18j, and it will be minus
12.
12 j
Yes.
square
Minus will be
plus minus, sorry, it is minus 12j square,
Yes.
right?
J.
J square. So what is j square?
J square.
J square is basically, j is under root of minus 1 multiplied by under root of minus 1. So j square is this. This is basically minus 1,
Minus 1.
right? So here it will give you 12 into minus 1. So yeah, so it will be
Plus
12 plus 8j minus 8j plus 18j. It will be giving you 10j
10j
and
plus
plus 12. So 12 plus 12, 24
J.
plus
10j.
10j. Right? This is how a complex multiplication works. And here, if you see, it's directly calculating it for us. Right? So now it's pretty handy. If you want to do some calculation with any complex numbers, you can directly do that operation here, okay? And you will get the result. Okay. Clear? So this also works the same way how we have done here. So this giving you exact result. So this kind of data structure or data type is not in other languages, right? I don't think it is there in other languages, but Python directly provides you, right? If you want to do a complex calculation in any other language, you have to do these calculations separately, right? You have to write down the program for this. Here, it's directly available. A complex data type is directly available that can be used. Okay.
Can we perform division operation with that?
So if it is possible mathematically, then it is possible here as well. So how division operation works? So division operators works like this, right? So if you do 4 plus 6j divided by 3 minus 2j. So how it works in mathematics? You multiply it with the complement of what is
2j.
Conjugate.
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 Yeah.
Yeah.
Conjugate. Right?
3 plus 2.
3 plus 2j. This gets multiplied by this gets multiplied by this, and it gets divided. Now you'll get a whole number here, maybe. And if you do this, why do you take conjugate of denominator? Because the denominator will become a whole number. To make the denominator as a whole number, we take the conjugate. Right? This is how we do a complex or division. Right? And if you solve this, you'll get 2j. That is 12 plus 8j plus 18j. It is 8j plus, I think, 18j minus 12, right, divided by 9 plus
9 plus 4.
6j
6.
minus 6j minus plus 4, right? So this will be gone. This is gone. So it is 26j, I believe, by 13. You get 2j. You're getting 2j? So to avoid all this calculation, directly you can perform this. Okay.
And what about modulus operator?
I think except modulus operator, you can't perform. You can't perform everything because modulus operator cannot be performed. Right? There's no logic on complex numbers of modulus operator, I believe. Right. So you can't do C1 modulo of 2. This is not. You can't do a mod of complex numbers. That's not a mathematical way of doing it, right? So there's no math behind it, so it's not allowed in Python as well. So except modulo, you can do all the arithmetic operations. So this is the modulus operation in Python, percentage sign. Right? We'll see it in detail.
Okay, and then what is then percentage if this is modular?
This is modulus. Percentage is not an operator, right?
Yeah.
What do you mean by what is percentage?
Percentage in the sense if I want to find out percentage of something, so I cannot use directly percentage.
No, you can't. You can't do
Okay.
that. You have to divide it by
Okay. The usual
multiplied by 100. The formula you have to apply.
Okay,
There's no direct calculation of percentage.
Okay.
Okay. Is complex clear? Okay, I'll take that as yes. So except modulus, you can perform everything. I mean, all the arithmetic operations, basically. Next, we'll see is Boolean. Booleans are true and false values, right? And why? What is the use of Boolean? So we know integers are used for integer, like numbers. Floating is also for numbers. Complex is also, let's say there's some complex number calculation. What is the use of Boolean?
When we need to compare two values.
Then we use comparison operator. Right?
Yes. Okay.
Conditional
Yeah,
check.
To define a statement.
define a statement.
It is in logic where we want the things will progress, program will progress when yes or no is there.
Correct. So whenever you write a condition, right, the output is always a true or a false, right? Yes or a no. Whenever you write a condition, it will always be either true or a false. So for that purpose, these true and false or Boolean values are used. Right? So B1 equal to true, B2 equal to false. The data type of both will be bool only. Okay. And one thing to note here is we have to understand true is usually considered as integer one value. False is usually considered as integer zero value. And in integers, all the numbers except 0 is true, and 0 is considered as false. This we have to remember, because this might be useful in some of the programming. We'll see. This was what Boolean is. Now we will see. Let's see strings. So we've already seen strings are characters or sequence of characters enclosed within single, double, or triple quotes. I'll just write quotes. Okay. S1 equal to hello. Okay. Print S1. Hello gets printed. Type of S1 class str. Okay. Now let's say S2 equal to hello world. Okay. So how many characters are there in this string S2?
It's 11.
How it is 11?
Space.
Yeah, space also will be counted as a character.
Yeah.
Okay. Anything, any character, any special character, space, comma, question mark, percentage, exclamation mark, equal to, anything inside, when it's inside a string or inside a double quote or a single quote or any quote, that becomes a unique character, individual character. Right? Even space is a character. Right? It holds space. It's not empty. Right? So hello is 5 characters. World is 5 characters. Space is 1 character. So there are 11 characters. We can, if there is a long string, we won't be able to count it. So there is a direct function called len or len to find out how many characters are there in the string. This is also called length of the string. Okay. Length of the string is equal to the number of characters in that string. Okay. And using len function, it can be calculated. Clear? Any questions here? Okay. Now, no question, we'll see something called indexing. Okay. Indexing string. Anybody? What is indexing? Any idea?
To index that particular character.
Yeah, that's fine. What is index that particular character?
Location.
Sorry?
It's a location of that particular character.
Yeah, location or the position. Right? Index is, yeah, giving a number or a location. Index is basically position or location of a particular character in a string. And index starts from
0.
Yes, start from 0 in Python. So the first character's position will be what? Or index will be what?
0. 0.
Right? And also how we use something called subscript operator. Square brackets is called subscript operator to fetch a particular character of a string using its index or position. Okay. So if I do S2 of inside the square bracket 0, okay, we'll get
H.
H. Clear?
Yes.
So let me write it down like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. So let me segregate this. This is not spaces of the string, but just for expanding and explanation purpose, I am putting this as this so that you understand. So if I tell you what is the index of the space,
5.
5. If I ask you what is the character at index number 8,
R.
R. So index starts from 0. And can you tell me is there a relation between length of the string and the index? If you want to generically write, index starts from 0 and ends at
L minus
minus 1.
L minus 1.
length minus 1, we can say.
L.
Yeah, L minus 1 or whatever, right? Or len of string minus 1, right? Simple. This is called positive indexing. Okay. There is something called negative indexing as well. Before this, so let's try to print some of the values. So if I try to print S2 of 10, what do you get?
D.
D.
D, the last character. If I do S2 of 11,
None or error. Error it will be.
error. Why?
So there is no character at 11th position.
There is no position 11 in this string, right? There's nothing at 11. There is no string at, there is no index 11 present in the string. So it will say index error, which is a runtime error, string index out of range. So the range of this string is from 0 to length minus 1. Anything beyond length minus 1 will give you an error. Clear?
Yeah, what will happen if we index at position 5? So for space, what will it show?
You'll get a space.
Okay.
Clear?
Yeah, it's clear. Thank you.
So index out of index error is clear.
Yeah.
Now let's go to negative indexing. Negative indexing is basically, it starts from, so it starts from the right hand side. Okay. Why it is required, I'll tell you. Let's say if it's a huge string, if it's a big string, how will you know what is the index of this guy? If you want to print the last character of any string, if of a huge string for which you don't know the index, how do you find out?
-1.
Minus
No,
1.
that's fine. But if let's say there is no negative indexing, then how do you do?
First we'll find the length.
Length -1.
Length minus 1.
Can you do this? Can you do this?
No,
Why not?
I don't think so. It will help. It will.
What's the problem in this? Syntax, is it? Logically, does it look good? So the last character is length of that string -1 is the last character index. Yes or no?
Yes.
So logically it looks fine, right?
Logically, it is correct.
Logical is fine. There any problem in logical issue here? No, right?
No.
It might fail because you are saying that it might be a wrong syntax, right? We can't write like this, maybe, right? We actually can. You can do this as well. First, find out the length, then do L minus 1. It will work. Okay. If I want to find, if you want to fetch the second last character,
-2.
-2.
Length -2. So on, third last character, length -3, fourth last character, length -4. Yes?
Yes.
So there is a shortcut for this. It's negative indexing. The last character directly, you can write -1.
So it will automatically perform length -1.
Seems to be, right? Because that is how it is working, right?
Yeah.
So negative indexing is working like this. So it starts from here. Starts from the last character, from -1, goes till the first character. So I'll just write minus here. Okay. -1 to minus minus
11.
What is it generically?
It is 0.
No. Yeah, from positive indexing it is 0, but starts from, like how we tell for positive indexing, it goes from 0 to length -1, right?
Right.
So it starts from -1 to
-11.
Minus L.
length
10.
Right? Right? Because 11 is the length. That's what we do. Because it's starting from not from 0, it's starting from -1. It will go till minus length in that reverse direction. Right? Okay. Clear? So if we do S2 of 0 and S2 of -11, both will give the same thing. S2 of -5 and S2 of 6. Right? S2 of 6 is W. X2 of -5 is also W. So when you use negative indexing, remember that it starts from minus from right to left. Positive indexing starts from 0 from left to right. Clear?
Yes.
If I do, let's say S2 of -20, what will happen?
Range.
Give an error.
Out
Index
of
error,
range.
out of range.
Yeah.
All right. Any questions here?
So why we use indexing? I mean negative indexing. Why we use it? Because
Okay.
यहाँ तो hello world लिखा है, तो we can count
Correct
it.
है. Correct है.
Yes, exactly.
I want you, the question is find print H using indexing. You'll start counting from here.
Yes. No.
All right.
Count.
It's convenient, right? -1, -2, -3.
Yes.
That's why.
Okay.
Yes, if a longer string, if you want to find some character from the end of the string, right? So it's pretty convenient. Otherwise, you have to find the length and do a -3 of that.
Yes.
Right? But instead of that, Python has given you a very straightforward thing, -3.
And if you want to count something in between, like for example, this is the class number 4. So we want to count the L from the class. So how we can find it's in the middle value, no? It's like that. So
Yeah,
how?
then it's a problem. But for that, we have functions on string.
Okay.
Okay, we'll see that later.
Yeah, sure. Right.
When we see strings in detail, then
Yeah.
we see how to find how many L's. We can also find how many L are there in the string. Which index is L present, and all those things we can do.
Okay.
Okay, so through indexing, like there is no function which can give the exact middle value directly.
That you have to find out, right? 0 plus length divided by 2.
No. Yeah, like there is nothing like that can give directly.
No.
We have to
Directly,
calculate
you have to calculate.
Okay.
Indexing will just help you to, give. Indexing is nothing but a position, right? So it doesn't give you something like middle position. That it doesn't give you. Either it give you 0 to length minus 1 from left to right, or from right side to left side, negative indexing from -1 to minus length. That's what it does.
Okay, got it.
Any more questions, anyone?
No.
But I think this is, I wanted to talk about, these are fundamental data types. Okay. Now let's see one concept which is called typecasting, and then we'll move to derived data types. Okay. What is typecasting?
To change one data type into others.
Right. Convert or change the data type of an object to another. The definition of typecasting. It is done using the class names that we saw, right? The data type name. Using that only we can change. For example, if a equal to 10. Okay. Let's say you want to change it to float. So you use float in brackets. You provide a. So it will convert 10 to float. What is that float equivalent of 10?
10.0.
10.0. There is an equivalent. First of all, you need to understand, is there an equivalent of that? From which type to which type you are converting? From the source type to destination type. The destination type should be a valid operation. So from integer to float, it's a valid operation. 10 can be represented as 10.0 in float. So it will give you 10.0. Clear? Now, similarly, if I do int of 50.67, can we convert this float value, which is 50.67, into an integer?
We can.
Yes.
What's the equivalent? Integer equivalent of 50.67?
51.
Sorry?
51.
Why 51?
Because after point it's greater than the value
Nearest integer.
Who told you that it will what do you say, round it off to the nearest integer? Okay, what do you write it as? You write this as let me explain in some other way. You write 50.67 as 50 2 by 3. Can you write like this? Can you write 50.67
Yes,
as like this?
Yes.
What is the integer equivalent of this?
50
What's
is
the
the integer
whole
part
number?
and 2 by 3 is the fraction part.
50 is the integer part, 2 by
Yeah.
3 is the fraction part. So
Yes.
integer equivalent of 50.67 will be 50, not 51.
Okay.
Yes. Okay.
It's not rounding off, okay? It will never round off. It will just convert, it will just fetch the integer equivalent of that value.
It's like a floor function.
Yes. So if you see 50.67 like this, making sense that it should be 50. Right? So if you convert 50.67, it will give you 50. So the integer integer equivalent of that, right? Integer value. So it's 50 only, right? So it will give you 50.
Ideally, it is whole part, not the fractional part.
Yeah, the whole part. It will ignore the fraction part. That's correct. Okay. Now, let's say we have int of 10, or let's write s1 equal to 100. Try to convert this s1 into integer. Is it possible?
Yes.
No.
Why yes? Why no?
Because it is a string and
It's in form of a string, but it can be converted into corresponding integer. It's not a name.
Okay.
It's a number.
So anything by your logic, you're saying that if any numbers are there in a string, that can be converted into a integer. That is your logic. Okay. There was someone who said no, it will not be working.
yeah, it's
Yes,
a string, so string cannot be converted into.
Okay, string. It is a string. It cannot be converted into an integer. Okay. Let's see. It gets converted into an integer. Okay. So it is not giving an error, means it is getting converted. We can confirm that by doing this
type
a and print type of a. Okay. So if inside a string pure integer value is there, only digits are there, it will be converting it into, it can be converted into an integer. Clear?
So basically, it means that in a string, if there are some integers, if you want to directly fetch those integers, we can.
What did I say? Pure. If only pure integers values are there, it can be converted.
Okay, string as a pure integer value.
This will not be fetching your the integer values, right? Even if there is a
float and complex will also be.
I'll come to that.
Okay, now it's clear. So basically, like if
any other character apart from digit is there, it won't be able to convert.
Okay. So does it hold good for float value also?
Yes, I'll come to that. It does hold good for float. But is this clear? If inside the quotes purely digits are there, it will be able to convert it into an integer. Otherwise, any other character is there, a space, any A to Z, any special character, anything is there, it will not be able to convert because there is no equivalent of integer for that character. Clear?
Yeah.
So float. What do you think?
100.45.
So 100.45 is a proper float value. Inside a string, we're trying to convert it into a float. It should work. Yes or no?
Yes.
Yes. Now one question to you guys. Will this work?
Yes. It should work.
Why?
Yes.
Okay, there are multiple yeses. There is one no. Why no?
Because the dot is there in the
Decimal dot is there, and you
Dot
said
is
that
there and also it's a
it
string.
should not be there, so it will not print. No?
Correct. It's not point, decimal point. It's a string and it has a dot. It's not a point. It is a character, which is a non-digit character. You're getting it? Why it understands in line number 64? Because floats structure has a dot in between. Okay. Integer structure does not have a dot. That's why, since it's a string and it will not be treated as a decimal point, it will be treated as a character. So it will fail. Clear? Is this clear?
Yes.
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 Now let's say my condition is I have this. Sorry. I want to convert into an integer somehow. Can you think of a way?
Yes.
How?
Firstly, convert into float, then float to integer.
Then float to, in the same line, we can write like this. S1 first gets converted into float. Whatever value we get, 100.45 as a float value, fed to the int function to get the integer equivalent, which is 100. Clear? Any questions here? Anyone?
Hello.
Yes.
Sir, can you please repeat the previous thing in 100.45?
So why it is not working? Because there is a dot in between. For integers, so this is for integers conversion. What did I say? Any string only will be converted, can be converted into an integer when purely digits are there inside that string. Purely. Is it a pure digit?
No.
We have a non-digit character here, right? Hence, it does not work. But it works in line number 64 because the float logic is different. It understands a decimal point, right? This is a valid float, so it can be converted into a float. Making sense? Any questions, anyone?
Yeah, no question.
Is it a valid program or valid line, correct code?
Yes.
What will be the output?
1.
1.
Integer, I said, true value is treated as 1.
1.
So it works. Integer equivalent of true is 1. Float equivalent of true is what? Will this work?
No.
No.
It works, right? 1.0. Yeah. It will work. So bool is the way to convert anything. So if I do bool of 200, is it a valid
Yes.
conversion?
Yes.
With output?
Yes.
True.
True. Any number except 0 is
True.
True.
If I give minus 100,
False.
true or false? Why false?
True.
Any number except
0
is a true. Negative or positive, doesn't matter. Okay. Only bool of 0 is false. Bool of any number apart from 0 is true. Negative or positive. Clear?
Yes.
Okay. Let's take this with. What about this? Valid or invalid?
Valid.
True.
Value?
True.
Right? Now, let's continue with Boolean only. Okay, this we have not seen, but is this valid?
Yes. True.
Yes. True.
Yes.
True, is it?
Yes. True.
So what will be the equivalent of false in a string representation?
Empty string.
What is an empty string?
Or
And how is it
quotes.
represented?
Quotes.
2 quotes.
2 quotes without anything, without any character, single or double quote is a empty string.
False.
empty string will be false.
What about none? Bool of none.
I will come to that. There is a question in chat as well. We'll come to that.
Okay.
Empty string is false. Anything else? Single character, space as well. Okay. Single space. Yes, it's a true value, not a false. Okay. Bool of none. Will first of all, is it a valid? What do you think? Just give a guess.
Yes, should be valid.
Should be valid. If it's valid, then what should be the value?
False.
Why?
None equivalent to 0.
So basically, it treats none
Empty.
as no value, empty value, right? Yes, right.
Yeah.
So it will be false.
False.
So you can convert any data type into Boolean. What will be the, how will we get false if it's a complex number?
0 minus 0 and 0 j.
0 minus 0, 0.
0 minus 0 j or 0 plus 0 j, anything?
Anything.
Oh, yeah.
Right? Right? Or what if I write like this?
True.
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 Point 1, it's a non-zero float, right?
Yes.
One
This-
question is there. 0.01 j is a non-zero value, non-zero float, but it is an imaginary part.
That's
So,
fine. Imaginary also is a non-zero imaginary part, right? That's okay. 0.1 j means 0.1 multiplied by under root of -1. So that's a
yes,
non-zero
correct.
number, right?
But this is an imaginary number. This is not
That's
an
okay. Whatever it is, the value is a non-zero number. Any non-zero
Okay.
number will be true.
Okay. Understood.
This is 0, gives you false.
Okay.
Any non-number zero number will be give you true.
Okay.
Yeah, good.
This complex number, when it is treated with the integer, like integer of 1 plus 0 j.
Mhm.
So will it give the integer value or what? Or it won't give?
1 plus 0 j is like this. It's a complex number.
Complex number. So if you want to take
What's
the,
your question? Yeah.
like if you want to use the integer function on this,
Let's say val equal to this. Oh, you mean to say, will it convert it into a integer? No.
Okay.
You cannot convert a complex into an integer.
Okay.
But otherwise, this complex number 1 plus 0 j is actually 1. 0 multiplied by j is 0.
No, but the data type is complex, so it will not allow. When you print also, if you see here, while printing also, this part shows you in the output, right? Logically, it's 0. But Python sees that, okay, explicitly somebody has mentioned it as 0j. The data type is different. It is not an integer. It has to be a complex. So to show that, it keeps that 0j part in with it. Okay. So you can't convert. Clear? So anything you want to convert to string, you write like this. You got a string. Get a string. Get a string. Get a string. Whatever you give to a string, it will put it under inside a quote, right? Pair of quotes, right? Clear? So you can convert anything to string. Any questions? Okay. Just give me a sec. Okay, let's take that part. Mutability. Any idea what is mutability?
To modify any string means to remove some characters.
That you are specifically talking about strings.
Yeah.
Right? So mutability is not only specific to strings. Okay. So you're right. You're not wrong. But you're talking specifically. I'm asking generically. What is a mutable object, or what is a mutable? Yeah. What is a mutable object?
That which we can
Object that can be changed.
Object
that can be
modified or changed. Without its memory location getting changed is mutable. Immutable object that cannot be changed or modified is immutable object. So can you tell me integers are mutable or immutable?
Immutable.
Immutable. Integers, I think indexing will not be possible, right?
That's fine. That's okay. But what did I say? If you can change the value without changing its address, it is mutable. So you can change the value, but the address is also changed. So this is not mutability. Integers are immutable. This is reassignment happening at a different memory location. So you can't change an integer. So integers are immutable. Clear? Same with floats. Right? So if I give 300.6 ID of B, value gets changed. Sorry, yeah, value gets changed, address also gets changed. So you're not able to change the object with retaining of its original memory location. So this is what mutability is. So floats are immutable, integers are immutable. Booleans also are immutable, right? Let's say B1 equal to true. ID of B1 is this. I say B1 equal to false. ID of B1 changes. What about strings?
Immutable.
Immutable. So there is one more way to check if the object is immutable or not. Here we have indexing, right? So str1 of 0 is h. str1 of 0, I can try to change h to z. Okay. So what I'm doing is telling str1 0th element, change it to z. Okay. This I try, I get does not support item assignment. I'm not able to change it. If I do str1 equal to 0, then it is reassignment. The memory address will change. So this is not mutable. But there was one way of changing it like this. This also is not working. So means strings are also immutable.
Right.
Making sense?
Yeah.
Yes.
Okay. So int is done. Float is done. Complex also is immutable. Same way how strings and float work. That is also immutable. None anyway one value. What it's immutable. Boolean is immutable. Strings are immutable. So all the data types that we saw are immutable till now, right?
Yes.
Yeah.
Okay. So we'll see a few of the objects which are mutable. So immutable, int, float, string, bool. Right? What else? Complex. None. Mutable. There are some objects which is called a list, set, dictionary. These are data types. We'll see it in a while. Okay. And here the list increases, tuple and frozen set. Okay. Immutable cannot be modified after creation. This can be modified. We'll see. Before we see set, we'll start with set. Okay. Then we'll see tuple. Then we'll see. Sorry, we'll start with list. Then we'll see tuple. Then we'll see set, frozen set, and dictionary. Okay. Before we do that, there is one more concept I just remembered before I forget. Object reusability. In remember we spoke about this. So num1 or var equal to 1000. var1 equal to 1000. The ID of var1 is some value 21904, right? If I do var2, ID of var2, will it be different or same?
Same.
It will be different.
Why it will be same? You've seen, right? The Python default implementation is even if the same value is there, it will create a new object at the new memory location, right?
Yes. So the values will be different.
The value will be same. To print var1, it gives you 1000. Print var2 gives 1000. But the places where they are stored, they are different.
Yes.
Right? So yes, that is the memory location 21904. Here this 1000 is stored, and this var1 is pointing to this location. One other 1000 is stored, which is at 21808, where var2 is pointing to. Right? Values are same, but the references are different. Saw this yesterday, right? Yes or no?
Yes.
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 All right. Now let's see some magic. Okay, what's the problem with this? If we write 100 times 1000 into in 1000 variables, all will be saved in different locations.
Yes.
Yes.
Yes. This takes a lot of memory. Okay. So here comes the Python reusability concept for memory optimization. Okay. So Devdatta, PyCharm is same ID. Yes, you are right. PyCharm works. They have some customization. That's why they keep same ID for bigger objects as well. Okay, but that's not true for Python. PyCharm has some customization. That's the reason. Okay, but that's not valid for Python. Okay, so let's we'll go to documentation later. Let's see this first. So it takes a lot of memory. So what happens is to avoid this kind of situation, what Python developers came up with. Python developers came with up with an approach of memory reusability for few objects, for few values. Okay, those are the values. Depending on the data type, it reuses. Okay, so let's see an example. A equal to 10, B equal to 10. ID of A is what? Just ID of B. By the above explanation, the ID of B should be same or different?
Different.
Different.
Different. Is it same or different?
Same.
Same. So what Python developers have done this, for few of the values, what they do is they reuse the memory instead of creating new objects. For integers, the value is in the range of -5 and 256. Both included. If you create any object on any variable, assign it to -5 to 256, all of them the same value, all of the variables will be pointing to the same memory location. Let's say you choose 50. Okay, 50 is in the range of -5 and 256. So you assign 100 times 50. All those variables will be pointing to the same location, to that one location where 50 is stored. It will not store 50 at 50 locations. Hence, optimizing the memory. Making sense? So what this does is actually, when Python program is loaded, as soon as the Python is loaded, okay, as soon as Python gets loaded, these values gets preloaded in the memory. Okay. As soon as Python gets loaded, these values gets preloaded in the memory. Okay. And when you assign a value, let's say A equal to 100, that time it does not create a new object because this object is already created. Okay. So just that variable goes and points to the location where 100 is already stored. Okay. Python preloads these values in the memory. Okay. As soon as the Python gets loaded. So let's take some example. So in the memory, it preloads these values. Okay. And let's say now you do a equal to, one sec. Let's say now you do a equal to 100. A is already stored in some memory location. Okay. So let's say OX 5111. This is the memory location. So now A starts to point to this location. It will not create the object because object is already, the value is already stored. And now you do B equal to 100. It sees that it is in the range. It has to be in the same, it's already there in the memory. B also starts and points to the same location. C equal to 100. C also starts with the pointing to the same location. The range is -5 to 256 for integers. Is it clear? Any questions here? Making sense? Okay. If you take A equal to 10, B equal to 10, C equal to 10, then all these memory locations are same. Yes, Navya, you're right. So A equal to 10, same memory location. B equal to 10, same memory location. C equal to 10, ID of C will be same. Is it same? Clear? So for integers, the range is -5 to 256. This is also called interning. Why am I not able to write? Interning. For memory reusability, the term is interning. Interning of integers. If somebody asks, so we'll say Python preloads the list of integers, the range of integers in the memory location in the range of -5 to 256. Both numbers are included. It means
so, sir, it means if we doesn't run any program, then this much memory is already occupied.
Already occupied.
Yeah, okay.
These values will be stored in the memory. And whenever you assign a value, it will not create a new object or assign that value to the memory. It's already there. That variable will just start pointing to that memory location where the object is already stored.
Reusability and this interning are same thing.
Same terms, yes. Same thing.
One more thing, apart from that memory location, there must be internal, some table must be created by Python so that variable and memory reference must be there in that. Otherwise, how can we check it?
Yeah. So what it does is, let's say you do, it's already stored. This 10 is already stored. Okay. When Python loads. So you do A equal to 10. So Python checks where is 10 stored. And then that reference, A starts referring to that memory location. And then all reference counting stuff and all those things, then it's the same thing. Right? So A just starts pointing to that location where 10 is stored already, which is this in this case, right?
Sir,
12304.
Yeah, it's whenever we open our Python, the memory location of variable where A equals to 10 will always be the same.
Yes, for that program.
For that program only, not for all the programs. Means whenever we run any program.
I am creating a new Jupyter notebook. Okay. Here I do A equal to 10, B equal to 10. Okay. ID of A, ID of B. These both are same, but it is not same as what it is here.
Yes.
Okay. For that program, it will be same, not for the new program.
Why it not happen for all the values?
It's happening for all the values, right?
It is.
Where it's not happening for all the values?
For like 4,000.
That's what I said. The range is limited.
I'm saying that whenever we assign a value to the variable, like 1,000 is assigned, then it will go to the heap area. The value first go to the heap area, and variable go to the variable area, and variable refers to the that address where that value 1000 is stored.
Correct.
And if we assign B to the 1000, B to 1000.
When we assign B to 1000, then again it will create a new object in the heap area. B will go to the variable area. B will point to the 1000, the new 1000 that is stored newly, right? It will be pointing to that location. But in case of minus 5 to 256, these values are already in the heap area. These values are already in the heap area. When you do A equal to any value, let's say 50, that's in the range of minus 5 to 256, right? That's already in the heap area. Python understands, okay, this is in the range. I don't have to create a new object. I just have to place that variable to variable area and make it point or refer to the location where 50 is stored. So it will know where 50 is stored and make that variable point to or refer to that memory location where 50 is stored. Clear?
Yeah.
Any questions here, anyone? What about floats? Will it be same or different?
Different.
Why? It is in the range, right?
That is applicable only for integer, maybe.
Yes, you're right. So that range is only for integers. If you write the float values in that range is not valid for float. For floatings, there is no reusability. Sorry, for float values, there is no reusability. Even 10.5, you create two times, it will be stored in 2 memory locations separately. Right? Here's the proof. Yes or no?
Yes.
So integers, reusability is there, interning is there. Floats, there is no interning. Right? For let's say Boolean value, B1 equal to true. ID of B1 is this. B2 equal to true. ID of B2, what do you think?
Will be same.
Why?
Because it's 0, 1. Boolean will be 0, 1. It's an integer now.
No, for storing, that's different story.
Okay.
But yeah, that also you can relate. Also, there is one more reasoning you can give, that Booleans are also interned because there are only 2 values. It was easier to basically these are used at many places. True and false are used at many places in the program. So it's better to intern them, right? Reuse them instead of writing or creating different objects. So these are also interned or reused, right? Similarly, false will be also stored, preloaded. True also is preloaded, false also is preloaded along with minus 5 to 256 integer values. Okay. Then none also is interned, okay, because there is only one value. None is also interned. Same value, I mean same memory location. Okay. What about strings? What do you think? Will they be interned?
No. No.
No. Okay. Is it same, different?
Same.
It means hello is getting interned. So basically it is not storing at 2 different locations. It's pointing to the same location, right?
Yes.
What it will be? Same or different?
Different.
I think
I. Because of the space, yeah, that's fine. But why is that? Is there any logic? Can you think of any logic behind it?
yeah, might be hello also will be used in many places.
Sorry?
Hello also will be used in many places like true and false.
No, that is fine. But why this is not being used? No, it's not like that. It can be any random value. Okay, that's not. That explanation doesn't hold good. It can be any random value. It's not only because it's a hello value, right? It can be any random value. So this will be different. Okay. Space is a special character, right, Devdatta? So what happens in string is the string which follows the rules of identifier or variables. Those are interned. So is it? Can this be a variable? Can this be a variable name? Hello space world can be a variable name.
No.
Can a variable have space in between? No, right?
No.
So it will not be interned. Hello, this can be a variable name.
Yes.
So it follows the rule of identifier or variable. So it is interned. But this is not always true. Okay. I'll give you an example. S5 equal to. Can this be a variable?
No.
Can a variable start with number?
No.
So for this also, it should not be interned. Yes or no? But it is. Okay. So sometimes it's so basically the funda is you can think about it as like this. For strings, the strings which follow the rule of identifier are interns. Naming convention of the identifier are interns. But few others are also interned. This is one example of that. So should not rely on it. There is no need to remember this. Okay. To be honest, simply you can. There's the best way of checking the ID and telling that okay, this is interned or not, right? You can check the memory location and tell whether it's reused or not. Yes or no? So, but the logic you can apply on a soft basis, you know, like how range is there in integers, -5 to 256 definitely will be entered. But there is no fixed rule in this. So I personally do not rely on this strings interning. Okay. Sometimes this gives weird, values. But this is what I have seen most of the times, 99% of the times, this holds true. If any string value is following the if any string value is following the rule of identifier, it will be interned. Is it following the identifier rule?
No.
No. Will it be interned?
No.
No, it's not interned. Right? So see, this is not following the identifier rule, but it is getting interned. So there are few exceptions to this as well, but definitely you can say that if that string is following the identifier rule, it will be interned. Okay. But there may be chances like, for example, this also is getting reused. So yeah, we can say, but just be very careful while, just check the ID if it's getting interned or not. But this is getting interned. Both are same value, right? It's following you can have a variable name like this. It's following the identifier rule. There is no limit, right? So it works. Clear? Any questions on this? String internal? So only integers, the range between -5 to 256 will be interned. Boolean will be interned. None will be interned. And few strings will be interned who are following the identifier rule, plus few other values as well we saw. Right? Others, nothing will be interned or used.
Manish, what if we use underscore in between hello and world? Will it be interned or not?
Should be, right? Because this is following the identifier rule, right?
Yes.
It is.
Okay.
No, underscore is not an exception. Because underscore, if you have, it is following the rule of identifier. So that's fine. Okay. Any more questions with this? No question. We can move towards the derived data types. Okay. So object reusability is clear. Let's see. Start from list. Start. List. Anybody any idea what is the list?
Collection of items.
Collection of items. What are these items?
Can be elements, strings, integers.
Data types.
Data types. And be integer, string, bool, none. A list itself. And these items are called elements. Right? It's a collection of items, or you can say a sequence of comma separated elements enclosed within square brackets. Okay. These are ordered sequence. Okay. Ordered sequence. What do you mean by ordered sequence?
Every data type will have index.
Yeah, they'll have index and they'll be in the same order. The order does not change after creation, right? They're ordered, like how strings were having order, right? Or collection of sequence of characters, right? So similarly, lists also are sequence of ordered elements, okay? And it can have any data type, right? This is called heterogeneous. Can have heterogeneous elements. Means it's not necessary that a list will have only integers. It will only have Boolean. It will only have strings. It can have mixture of all the data types together, right? So let's see, L1 equal to, you can have 100, 65.89, 89, Python, true, none, 7 minus 5J, comma separated values enclosed within square brackets having elements of heterogeneous data type is called a list. Clear? Questions here? So the way we defined is the same order, right? It's in the same order. And if there is ordering sequences as set correctly by someone, we can index. If I do L1 of 0, what it will give me?
100.
100. This is 0, 0th element, first element, 2, 3, 4, and 5. So L1 of 0 will give me 100. L1 of negative indexing is there in list as well. L1 of -1 will give me
7 minus
7 minus 5. J. That's the last element of the list. Will this work? If this works, what will the length?
6.
6. There are 6 elements in the list. Length of L1 will give you the total number of elements in the list, which is 6. Clear? How, if I want to fetch Python, how do I fetch?
L1
of
2.
L1 of 2.
Yes.
Right? Is it a correct, valid statement? Is it a valid statement?
Yes. No.
Why no? Why yes?
No.
We have list
We
inside
have
list,
only.
it can work.
Yeah, because a list of list will be there, it will work. Okay.
Yes.
Okay. If I do this, is it valid?
Yes.
Yes.
What will be stored in S?
Python.
Python.
Can I do S of -1? Can I do?
Yes.
String.
And
N
will be there.
N will be there.
Yeah.
What's wrong with this? What is L1 of 2?
It will print N. L1 of 2 is Python. And then
Sorry. Blah, blah, blah. What is L1 of 2 is Python? L1 of 2 is Python. I'm doing Python's last element, last character -1.
Yes.
It should give N.
N.
Right?
Okay.
Getting it? So when I write L1 of 2, treat this as a string because that's a string, right?
Okay.
L1 of 2 is what? String, right? On string, I'm doing indexing. String on indexing is possible. Sorry, indexing on string is possible. Right? If I do L1 of 0 of 0, this is wrong because I'm trying to do an indexing on an integer, which is not possible.
Yes.
Type error. You can't do indexing on integers. But if any element is part of the list, which is that element also supports indexing, then we can do it. No problem. Clear?
Yeah.
Yes.
Now, I said a list of any element can be part, any data type, any object can be part, can be an element of the list. So a list also can be an element of a list. Is this valid?
Yes.
How many elements are there?
5.
If I do len of L2, this is 1, this is 2, this is 3, this is whole thing is 4.
Yes.
This is 5.
Yeah.
So it will be 5. If I do L2 of 0, what will I get?
10.
If I do L2 of -2, what will I get?
1,
2 as
list.
a list. L2 of minus 2 of 0. Is it valid?
Yes.
Yes.
No.
Yeah, one will be
You'll get
yes.
1.
Yes.
Okay, okay.
Getting it?
Yeah.
Yeah.
Valid? Yes or no?
Yes.
Yes.
Yeah.
Anybody saying no? What will be the output?
Yeah.
L. L2 of 3. What is L2 of 3? L2 of 3 is 0, 1, 2, 3. This is a list. So L2 of 3 is a list. We are doing an indexing on top of it. L2 of 3 is a list. This list minus 1 is what?
Hello.
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 Till here we get hello.
Yes.
Then I'm doing of 2. Can for hello can we do indexing? Yes, we can. 0, 1, 2. L.
Okay.
Clear?
Yes.
Any questions, anyone? Clear? L2 of 0 is 100. Sorry, L2 of 0 is 10. What did I say? Lists are mutable or immutable?
Mutable.
Mutable.
If I do this, will it work?
Yeah, it's
Yeah.
Yes.
Before this, let's see the ID. And I do L2 of 0 to minus 20. First of all, it will change. This was not working with strings, right?
Yes.
Yes. So strings are immutable, lists are mutable. So we can change the value in place, right? So we change the value of the first element, 0th index value from 10 to minus 20. The memory is also intact, right? So one thing to understand is this entire list will not be present at this memory location, right? The list object will be at this position, and each element will be separately stored in separate locations. Okay, so there will be mapping done, okay, internally. So we don't have to worry about it, but we have to understand it. Okay, clear? Any questions? So lists are
Mutable.
Clear?
Yes.
Can be modified. We just saw.
What is the location which is the ID location which is present here?
Your voice is little
Showing
low.
for what?
Can you please be louder? Okay.
Yeah, I'm asking like this location 19260. What does it represent for which thing actually?
Memory location of this L2. So what it does is, so let's say this is the location ending with 576, right? So what it does is, I said it will create an object, right? In this object, it will have, okay, this is a list. And it will have all the information where these objects are there, which is 0th index, which is first index, and all those things. Each individual values will be stored separately, right? Okay. Because if you
At
do
that
ID,
location only object. Okay.
sorry, go ahead.
Yeah, so I was saying at this location only the object will save, or
Yes.
the object will be saved, right?
The list object will be saved at this location. Individual values will be stored at some other place. If you do L2 of 0, this guy is stored somewhere else. L2 of 1 is stored somewhere else, individual values, because you can't store in everything in entire list in the same memory location, right? And these individual values are integers, so they'll be stored somewhere else, obviously, right? So when we create like this, Python internally creates, right? Okay, these individual elements will be stored at some location. This L2 memory address is this. This list memory address is this. This guy will have all the information where all the elements are, and in what sequence you have created. In that order, it has to maintain all those things, right? All this information will be stored.
Suppose if a list is having the integers in between -5 to 256, then it will be saved on a single memory location.
Yeah. So let's say L3 equal to 10, 20, 10, and 100, right? So ID of L3 of 0 will be same as ID of L3 of 2. Both are, these are 10 individually, they are stored at same location, and the value is between -5 to 256, right? Making sense?
Yeah. Thank you.
So lists are mutable. These are sequence. All heterogeneous elements can be part of a list. We have indexing, and it can be modified. Okay. So there are other ways also. There are multiple functions related to lists as well. We'll see that those functions when we see lists in detail. We have a separate class for that. So right now we can see other data type, which is tuple. Can we get an ID of entire list in one line? Yeah. I mean, ID of list you are getting right anyway. What do you mean by can I get ID of entire list in one line?
Okay. I understand. This is the starting address. Then
Yes,
after that,
starting address. Correct.
Yeah, I understand. Got it.
Cool. Elements will be individually stored in their memory locations separately.
Yeah. Okay, thank you.
Yeah, no problem. Okay. No more doubts. We can move to tuple. Yep. Anything, Atul?
Yes, Manish. Does that mean that all the mutable objects will point to the same memory location always? As
Yeah,
we
if you
saw.
change them, if you change them, the memory addresses will not change. They will change in place. Yes.
Okay. So in
That's
list,
the whole point.
yeah. So in list, if we are changing the elements only.
Yeah.
When we
In
change
any
the
element, you can
elements,
change it. Yeah. It will be changed. It will allow, first of all. Yes. It should allow. So if it's allowing, and also the memory will not change. So that makes it mutable. Yeah.
Okay.
Memory of the list will not change.
Okay. Fine.
Okay. Tuple. So tuples are also ordered sequence of heterogeneous tuple are ordered sequence of elements. Elements are comma separated and enclosed between round brackets. So it's same as lists till now, right? But only difference is comma separated within round brackets. But there should be some difference. So, but these also take heterogeneous elements. Elements can be heterogeneous. This also is fine. The only difference between tuple and list is tuples are immutable. Can't change tuples. Okay. So I do T1 equal to 120.7. Hello. True. The difference while creating also, it's round brackets. It's not square brackets. If you create with square brackets, that will be a list. This tuple. Okay. So same way indexing is possible here. T1 of 0 will give me 1. T1 of 2 will give. Hello. T1 of 2 of 0 valid. H. Clear? Length of T1 will work. What is the length of T1?
4.
4 elements are there.
Yes, 4.
Negative indexing will work. For indexing, square brackets, okay? The last element is true, so you get true. Right? But if you want to change the value of first value 1 to 10, does not support item assignment. Tuples are immutable. Clear?
Yeah.
Any questions?
Can we add a fifth element to this tuple?
No, we can't.
Okay.
Nothing is allowed. In list we can add, remove everything because that's mutable. Tuples are immutable. We can't change it after it's created. You have to create a new tuple.
Okay.
While tuple has been created, what is the use actually? It is not
What's the use? Okay. What's the difference? It's not modifiable, right? You cannot modify after creation. So any object that need not to be modified. Can you think of anything that is fixed and you should not be modified? Any random values that should not be modified?
Constant.
Sorry?
Constants.
No. Constants are there. Yeah, that can be one thing. Yes. Constants are there. You can put the constants in tuple. Or let's say you want to do something with the months of the year. There are 12 fixed months with the fixed names. Should not be changed. So you put it in a tuple instead of a list. That's a better way of doing it, right? Isn't it?
Yes, yes.
Aadhaar number, driving license number should not be changed. Passport number should not be changed, right? Those kind of objects can be put in a tuple.
Like initial data, something you have received from somewhere and you have to work upon that, and that should not be changed.
Yes. So this helps us doing that, right? If any programmer by mistake also tries to change it, it will not allow. In between, if your program is tend to change it, put it in a tuple. So that for that reason it is being used. Also, tuples can have duplicate values. Even lists can have duplicate values. We have seen that, right? I think L2 or L3. Yeah. Duplicate values are allowed both in tuple and list.
Can we put a list inside a tuple?
Yes, we can. We can put a list inside a tuple. We can put a tuple inside a tuple. We can put a tuple inside a list. Everything is fine.
Yeah.
But you can, assignment is not a problem. So if I do let's say, what is the len first of all? Len of 3,
3.
3. Right? If I want to fetch the list,
-1.
-1 or 2?
Yeah.
Anything? Right? If you want to fetch 3.
Yeah.
-2.
-2 or 2. Both are same. Right?
Yeah.
Let's use -2, whatever. Now, my question is, okay, before my question, we'll establish tuples are immutable, lists are mutable, right?
Yeah.
If I want to change the value of 3, is it possible in
Yes.
T3?
Yes.
Yes.
Why is it possible?
Because
Oh,
it's
Tuples
a
are
list.
immutable.
No.
List
Then
Lists are
List
mutable.
mutable object.
No, because if value will be changed, then tuple will be changed. No, it won't be the same.
yeah, they're both are arguments. Both are argumentative, right? People are saying it's a list, so it should be allowing to change it. You are saying it's a tuple, it should not be allowing to change it. Right?
Because
Both are correct.
because maybe the priority of the tuple is higher than the list. Yeah.
Okay.
No, but the element, the list is the element of a tuple. So we cannot change the element of the tuple.
But this element is not an element of a tuple. This 3 is an element of a list. This list is the element of tuple. If you want to change the entire list, that's not possible. That's fine. You're getting it. So T3 of -1, if I try to change it to some other list, let's say 10, 20, whatever, this is not allowed. Okay. Here, T3 of -1, so T3 of -1 of 2 equal to 300. Okay, before that, what is T3? Are we operating on T3 or are we operating on T3 of -1?
T3 of
T3 of -1.
T3 of -1 is the list, right?
Yes.
So it should work or not?
Should
Yes.
work.
Will work.
Does not give an error. So it works, right?
Yes.
So you have to understand, we are changing the value of a list. We are not changing the value of a tuple on a deeper level, right? So it will work. When we try to change directly the T3 value, right? Any element of T3, that's not possible because tuples are immutable. Here, when I do T3 of -1, I fetch and I get the list, which is mutable. So T3 of -1 of 2 is possible that I can change it from 3 to 300. That's how it works. Making sense?
Yeah, but does it work in the case of list in the sense of tuple inside of the list?
Tuple inside of a list, we are trying to change the tuple. That will not allow.
Okay, same thing will happen.
Yes. If we change the entire tuple, which is the element of the list, that will be allowed, right?
Understood. Thank you.
Cool. Any questions here? Can you repeat this part again? Yes, I'll do that. Okay. So what we had here is, we had T3, which is T3 equal to 10, 20, and the third element of T3 is a list. Clear? Yeah. Aditya. All right. So when we want to fetch the value, the list, we'll use T3 of 2.
Yes.
Right. So, and we want to fetch 3, we'll fetch as T3 of 2 or -2, whatever. Right. So we are trying to do this. So T3 is this. It was not this. It was 10, 20, and the third element was a list 1, 2, 3, 4. So what we are doing here is T3 of -1 of 2 equal to 300. Will it change or not? You're seeing that it's changing. Yeah. The question is, why is it changing? According to you, should it change or should not it change?
Ideally, it should not, because you said that in tuples it's immutable, so it cannot be changed.
Correct. So, but are we changing the tuple or yeah? Are we changing the tuple or the list?
We are changing inside the list, but overall it's a tuple.
But overall it's a tuple, but it is not something like this list is a separate object, isn't it?
Yeah, it is.
So individual, it has its own individuality.
Yes.
So individually, if you see this, if you do something of that sort, let's say where equal to T3 of -1. Now where this you are treating as a list, but not T3 of -1 you are treating as a list. If this you are if where is a list, this also is a list. If you can change where, you should be able to change T3 of -1.
Got it.
Cool. Any more questions, anyone?
Yeah, actually, we need to use print function to get output, right?
Yes, that's Python. Yeah, in Python, we have to use print function. As I said earlier, in Jupyter Notebook, the last line gets automatically printed. So I'm not using it here. I'm sorry. I'm used to that. So it's kind of a shortcut. So, but print has to be used in a normal Python program. You're right. Okay. Any more questions?
So
see the
like here the priority is not defined, like which gives that.
There is no priority. You have to understand what is that object individually. The individual object's property will take effect.
Okay, so maybe I don't know. Like okay, so this inside inside the tuple, the list is stored at a separate memory. So it is
Exactly.
functioning on that memory itself, where the list is pointing out.
Correct.
Okay.
When I change this value, the memory address of T3 was same. It has to be same. Doesn't matter, because the object we are changing, that is an element of a tuple, but it is a list, which is an individual element, which is mutable. So that will allow.
Okay. Okay.
Okay. Any more questions, anyone? Can you talk more about indexing for lists? Okay, I can do that. So let's take L1. Okay. Yeah. So indexing of list is same as indexing of strings. If you've understood the indexing of strings, it is exactly the same as that. So indexing is nothing but positioning of the lists, right? And position or index starts in Python from 0.
Yeah.
And goes till length -1.
Length -1. Yeah.
0, 1, 2, 3, 4, 5. Length of this is 6. So this element, the last element is length -1. Right?
Yeah.
And similarly, the negative indexing, this is -1, this is -2, this is -3, this is -4, this is -5, and this is -6. Same as strings. Starts from -1, goes till minus length.
Yes.
Clear?
Yeah. So you earlier had some examples for indexing for a list. So I was talking about that actually. So
let me see that. One sec. There is a stuck. Yeah. Okay.
Yeah. The L2 I was talking about. Yeah.
This one?
Yeah.
Okay. So how to okay, here also you tell me the index. So what is the index of -20?
0.
This is 1. This is 2. This entire list index is
it's 3.
And this is 4.
Right.
Clear?
Yeah.
And there are 5 elements.
Right.
Right. Now, if I have to fetch this guy, the entire list, how do I fetch?
L2, 3, I guess.
0, 1, 2, 3. Yes.
1, 2, 3.
Right?
Yeah.
Now, this again is a list.
Yeah.
Which has its individual indexing.
Right.
Which is 0, 1, 2,
2. Yeah.
If I want to fetch the value 2, how can I fetch it?
L2 3.
L2
3.
This of 2.
Yeah.
So
Right.
this is L2 of 3.
3.
Right.
Of 2 is 2.
Right.
Sorry.
Right.
1.
It's 1.
Yeah.
Sorry. 1. 0 and 1. Right?
Yeah.
I get 2.
Right.
If I want to fetch hello, same way, L2 of 3
Minus
of 2 or minus 1. Anything.
Right.
Minus 1 is the last element.
Right. Yeah.
So I do L2 of 3 or minus 1 gives me hello.
Right.
Now, can I do indexing on string?
Yes.
Yes.
Yes. So this is my string. L2 of 3 of 2 is my string.
Right.
So I can do this to fetch H.
Yeah. Right.
Getting it?
Yeah. Now I got it.
All right.
Thanks.
No problem. Ramchandran, indexing and slicing are different. Yes, they are totally different. We'll come to slicing when we see lists and strings in detail. Okay, we'll see slicing there. Slicing is in slicing in strings is fetching the substring from a string. Slicing of list is fetching a sublist from a list. We'll see that. It's very interesting. Okay, but not now. We will see it when we in depth see these data structures or these data types. Okay. Clear? Any questions, anyone? So let's stop for today.
Did you enjoy the video? I'm sure you did. And just like this, you're going to enjoy an absolutely free personalized career guidance call with our counselors for free. Call on the number below and book your slot today.